Qualitative Analysis Lab 2, and we are looking at page 4, the flow chart, and doing a known. I'm just slipping back to page 3 with the instructions. We did a data table in the last video. Now we're going to study the data table, use it to complete the flow chart, and then we're going to put magnesium, calcium, should be magnesium, calcium, strontium, and barium in one test tube. And then what we're going to do is we are going to add, we're going to try to separate each ion one at a time. So this should be magnesium, calcium, strontium, barium. Just notice that. And then we're going to find things and separate them one piece at a time. All right. Next step is going to our flow chart. And if I had magnesium, calcium, strontium, barium in a test tube, I'd add OH minus. Remembering from the last data table, there was only one thing that formed a gel-like precipitate with OH minus. The others had no reaction, and that was the Mg. So we got MgOH, which was a gel-like precipitate. So the Mg would go here, and then the calcium, strontium, and barium are going to go here in this. So you'd centrifuge it, you'd skim off the Mg, and that would be gone. You could separate it. Now you would add CrO4. And CrO4 is another one where only one thing formed a precipitate, and that was barium. So you get rid of the barium here, that would form a solid, sink to the bottom, especially after centrifuging it. And what would be left would be the calcium and the strontium, because we already got rid of the magnesium up here. So now we just have calcium and strontium left. And then we add SO4. And there's two things that form a precipitate with SO4. One is barium and one is strontium. Well, barium already formed a precipitate and was gone up here. So it's going to be strontium right here. So the strontium is going to go in right here. And the calcium is going to be left behind. In the last reaction with CO3 minus 2, everything forms a precipitate with CO3 minus 2. We've already separated them out. So the CO3 minus 2 test is a verification test for calcium right here. So going back through and looking at this, you have precipitating one by one. You get the magnesium here, leaving behind calcium, strontium, and barium. Then you get barium here, leaving behind strontium and calcium. Then you get then you get strontium here, leaving behind the calcium. And then the CO3 test is a test for calcium right there. So we're going to follow that flow chart. I think I'm going to clear off of this so you can actually see it a little bit better. So I'm going to go and stop the share, and then we're going to follow this one step at a time. And hopefully we're going to get something at each step. And we'll see what these look like when they're all mixed up. It might look a little bit different than on the data table. And it should parallel to what we see in our unknowns. Here we go. I'm looking for OH. I'm going to add this here. And let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one's kind of interesting because you can see maybe just a little fogging near the top, but it doesn't look like much. And what I'm going to do is just give it a quick mix. I'm going to put this on and really just do one quick flick. Okay, maybe 2. Okay, move this up and down, and now it looks kind of hazy, but there's almost like bubbles in there. And hopefully you can kind of see the bubbles in there. And I think this is going to centrifuge out. It's almost like a gel-like, okay, thing I can think of is kind of looks like fish eggs. I'm going to put it in the centrifuge, which I don't think you can see right here. You can see now I'm going to balance it. So I got one in this side, one on the opposite side. This is just a blank solution here. And hopefully this is going to spin out. Sometimes this one's kind of fussy. I'm going to spin that around, but that should be the magnesium forming that gel-like precipitate. If you don't mix it, and I think you got to do that quick invert up and once or twice, then you might not see that. Okay, and then the magnesium could interfere with other steps too. So you got to get that gel-like thing, and it's got to be a quick ready mix. Do that one. Just letting this go because I don't know how well. If you get this one tastes a little fussier, it needs to centrifuge real well. I'm going to get ready. My next step would be to add the CrO4. I'm away from my flow chart. I think we can see these precipitates in that. Okay. Slow this down. Make sure my fingers aren't in there. Oh, look at, there's cloudiness at the bottom. It looks fluffy like Three Musketeers. Okay, so that is going to allow for a nice transfer. And I'm just going to decant it. Okay. And I'm going to do that. I might leave a drop of liquid, but I keep that solid there. So that's my magnesium or magnesium hydroxide. I don't care about that. This would contain the calcium and strontium and barium if we had it. And we know we had it because we put all those things in. So the next step is I'm going to add CrO4, which is a test for barium. And you should see clouds right away. And I think this, I don't want to say it clearly got cloudy right away, but it did get cloudy right away. Okay, I think pretty obvious step right there. So I'm going to centrifuge that. And what happens is the barium goes with the chromate, forming a precipitate, but the strontium and the calcium should be left behind. Again, probably give it a little bit of extra time in the spinner, then I won't have to redo it. Okay. And that one looks pretty good. Okay, so spinning that around and getting ready for my next test, which is SO4. All right, I think that's good. Pull this out, and that's my blank with the water. Let's see how we did. Okay, so you can see there's stuff at the bottom. I don't know if you can see that well, and then it's kind of frosted on the side of the glass too. So as it gets centrifuged, it's facing this way. So this side of the glass doesn't get painted the bottom in this because of the angle that this thing is in the centrifuge. Okay, that's one that's kind of harder to clean up, but I'm going to transfer this to a new test tube and hopefully have a nice clear solution, some yellow color tint in it, but that's about it. Ready to go to the next thing. Okay, the yellow tint tells me I probably have an excess of chromate, which is good, because if I have an excess of chromate, I should have used up all my barium, which I want to do because I don't want the barium to interfere with the next step. Okay, my next step, I'm going to add SO4. This is worth watching as I add this. And I usually add a couple extra drops here. This is the least clear cut of the precipitates, and we're going to see what happens. I'm not seeing much, but it takes about 30 seconds and it tends to frost the glass. And like if you put like a mug in the freezer and then it kind of frosts that glass. I'm starting to see it kind of frosting up the glass on the outside. So this is by far the weakest test. And so I do like 3 extra drops of the sulfate, and then I'm going to spin that. And I think that will help show the frost in the glass, but it's about a 30-second delay. You don't get the precipitate right away. This is unusual. Most of them you see the cloudiness right away. But for a positive test for strontium, it's that frosting of the glass after 20 or 30 seconds, it kind of fades in. That's by far the hardest one to distinguish right there, but I think we can do it. Okay, I'm going to stop the spin here. And I'm curious to see what this looks like online. There's not a lot of stuff there, but there's that haziness on the glass. So it's not sitting in the solution. It's haziness all over the glass, and that's what we look for with strontium, is how it frosts the outside of that glass. Okay, now I'm going to put that in a different test tube and just going to compare it maybe to another test tube. I think you can see that haziness looks a little different. This is the one with strontium that probably looks more hazy than the one that's just distilled water. Be interesting to see what you're seeing in the video when I relook at that. Okay, so I'm going to skim this off so I don't have that frosting on the glass anymore. And yeah, I can see there's that residue left on that frosted glass for strontium, and that is what we'll call a positive test for strontium. Okay, this is the calcium. Now, when I add the CO3, it should become cloudy right away. I'm less worried about the amount of precipitate, but I should see clouds right as I add the drops. To me, that looks like it's clouding up. Now, it looks hazy, but there was that right as I added the drops, it was definitely getting cloudy. And if I let this go, if I spin this around, it will be a precipitate formation right there. Okay, so just in review of the different things that we did, see if I'm putting these things in the right spot, is I'll go back to our flow chart, stop the share, make sure we got this. So the first step, I added OH and it had like that, I mixed it. It didn't look like much happened, but when I mixed it, I got that gel-like precipitate, which sunk to the bottom here. Okay, it looked kind of fluffy as I centrifuge that off. That was a positive magnesium test. Very important to give that a good mix to do that. The next step, the CrO4 test, is very obvious, gets cloudy right away. Typically, I get a good amount of precipitate right here, and that test tests for barium. So that second test, my precipitate is barium right here, and leaving calcium and strontium here. Then I add the SO4. This is the weakest test of them all, but it takes about 20, 30 seconds, but it tends to frost the glass. I always centrifuge that step. I think you can see like the frostiness on the glass here. That is a positive test for strontium. And then the last one is CO3, and that should get cloudy. Notice it might not give a huge amount of precipitate that I could have it sink to the bottom, but it gets cloudy right as I add the drops. And that's when I look initially at that. See, is it getting cloudy when I add the drops? And if so, that would be a yes there. So we got a yes for all 4 precipitates, which is expected because I put all 4 in there. And that would be the positive test you'd look for in an unknown, whether you have those things happening or not. All right, thanks for watching. Let me know if you have any questions with that.